There's this really powerful idea in computer science that's kind of quietly running our digital lives. I'm talking about everything from how your phone squishes down data to how AI actually learns. It's called a greedy algorithm, and its whole philosophy? It's surprisingly simple. Just make the best choice you can see right now and, well, hope for the best. Think about it. When you have a problem with millions, maybe even billions of possible solutions, how in the world do you find the single absolute best one? I mean, trying to check every single option, that isn't just hard. For a computer, it's often literally impossible. And that's exactly where the greedy approach comes into play. It's a shortcut, a really intuitive one that honestly we all use every day. Instead of getting paralyzed trying to figure out the perfect long-term plan, you just make the choice that gives you the biggest win in the immediate moment. Okay, so here's our game plan for this explainer. We're going to start with the core idea of the greedy approach itself. Then we'll dig into how these algorithms actually work. We'll look at the different flavors they come in, tackle that huge trade-off between good enough and perfect, see why any of this matters in the real world, and finally peek into what's next for this incredibly powerful concept.
All right, let's dive in. So, what is the greedy approach, really? At its heart, it's all about one simple rule. Make the best possible choice at every single step along the way.
So a greedy algorithm isn't trying to see the whole chessboard, not at all. It builds its final answer one piece at a time, and at every stage, it just asks itself one simple question. What is the single best move I can make right now? Then it makes that move and adds that piece to the puzzle. The big hope is that by making a series of these really good short-term choices, you'll end up with a final solution that's either perfect or at least really, really good. To really get how this works, let's use an analogy. Picture the algorithm having a dictionary full of every single possible building block it could ever use to create a solution. The whole process is basically just a loop, right? First, it selects the best-looking piece from its dictionary, the one that gives it the biggest bang for its buck right at that moment. Then, it adds that piece to what it's building. After that, it has to update the problem, basically figuring out, okay, what's left to do? And then, you guessed it, it just repeats the whole thing, again and again, getting a little bit better with every single pass. Now, here's a key thing to remember. Greedy algorithm isn't just one single recipe. It's more like a whole family of them. Yeah, they all share that same core philosophy, make the best immediate choice, but they can go about it in some pretty different ways. So, for instance, you've got something called a relaxed greedy algorithm. It's a bit more careful, kind of blending its last guess with the next best option to slowly refine its answer. But then you have the thresholding greedy algorithm, which is way more aggressive. It looks at all the options, draws a line in the sand, and just grabs every single piece that's good enough all at once. Two very different tactics, but they both have that same greedy soul. And this all leads us to the absolute core tension of greedy algorithms, that fundamental trade-off. It's the choice between getting a pretty good answer really, really fast versus chasing that perfect answer that might just be impossible to ever find. As the source material here puts it so well, the whole point is to build suboptimal yet good approximations. See, the goal isn't perfection, it's usefulness. It's about getting powerful, practical answers when perfection is just completely off the table. Okay, so that's the million-dollar question, isn't it? If we're not getting the perfect answer, we really need to know how close we are. Are we talking about a wild guess, or is this thing reliably close to the real deal? Well, what's amazing is that for a lot of these really powerful greedy algorithms, we actually have a mathematical guarantee. It's not just a guess. Researchers have proven that the error, that's the gap between the greedy answer and the perfect one, gets smaller at a really predictable rate. So that n to the minus 1/2 you see, don't worry about the math. What it really means is that the more times you let the algorithm run its loop, the closer it gets to the best possible answer. And it does it in a way we can actually measure and, more importantly, trust. So here's the trade-off in a nutshell. On one hand, your computational cost. How much work your computer has to do is incredibly low. So much lower than trying to check every single possibility. And what do you get in return? A solution that is good. Often it's exceptionally good, but you just don't have that 100% guarantee that it's the absolute best answer every single time. So why do we care so much about this good enough approach? Well, because it's the invisible engine running behind the scenes in so much of the technology that we use every single day. I mean, they're absolutely essential for compressing data, for making our files smaller so we can send them around. They're right at the heart of machine learning and neural networks. And maybe most importantly, they help us tackle something called the curse of dimensionality. That's just a fancy way of saying that when data gets super complex with tons of features, it gets really hard to analyze. Greedy algorithms are brilliant at cutting through all that noise to find the patterns that actually matter. And don't think for a second that this is all figured out. Not even close. The stuff we've been talking about is part of a really active and exciting frontier in computer science. Seriously, researchers right now are constantly pushing the boundaries. They're asking, can we make these things even faster? Can we get them even closer to the perfect answer? Can we invent totally new kinds of greedy algorithms for problems we haven't even thought of yet? This whole quest for smarter, more efficient, good enough solutions is driving some really huge innovations. At the end of the day, as our world just keeps generating more and more data and our problems get more and more complex, chasing after that one single perfect solution, it's just becoming less and less practical. So you have to wonder, right? In this age of big data, maybe the speed and reliability of a good enough answer isn't a compromise at all. Maybe it's the new definition of perfect.